Hello, what's up guys? So today I'm going to make a flashing LED circuit using just two transistors, namely a PNP transistor and a NPN transistor. So have you ever thought how you can make a stable multivibrator using only two transistors? If you haven't, then follow this video till the end. So we are going to need two transistors. One, we need an PNP transistor and a NPN transistor. First we need to connect the collector of your PNP transistor to the base of the NPN transistor via a 1 kilo ohm resistance. We are going to use BC547 and BC557. So we will then connect the base of the PNP transistor to the emitter of the NPN transistor via a 1 mega ohm resistance. I will be later on explaining why we are using 1 mega ohm. So before that we will connect an LED to the emitter of the NPN transistor and connect it to the base via 1 mega ohm. And then we need to connect the base of our BC557 to the collector of the NPN transistor with a capacitor, electrolytic capacitor. And we will connect the emitter of our PNP transistor to the positive rail and this terminal to a negative rail, and we can apply a voltage of plus 5 volt. So this one will be the positive terminal, this one will be the negative terminal, and we need to connect a resistance of 22 ohm. So those of you who are interested to know the working of this circuit, I will be explaining it now, and those who are interested just to build the circuit, you can skip this part and go to the breadboard part and the circuit diagram. Let us name this transistor as T1, capacitor as C1, this resistance as R2, this one as R3, this one is R1, this transistor as T2. So for the time being, let us remove the LED and draw the equivalent circuit. So this is the equivalent circuit of this one. What happens here is this circuit is nothing more than a two-stage C amplifier. with a positive feedback added by the C1 capacitor. This T1 transistor starts to conduct via this R1 resistance, which pulls the base of this T2 to high. This starts the T2 into conduction, and then in turn this T2 pulls the collector of the PNP transistor at low. At the same time, the C1 capacitor starts to charge very quickly. This capacitor charges very quickly as due to the large charging current. So the path can be written as this, as if this one is 5 volt, then plus 5 volt to T1 from the T1 from emitter to base. So base, emitter to C1, then to T2, collector, emitter, then to ground. So when the capacitor is fully charged, the T1 base current is now provided only by R1 resistor, and in order to this circuit to work as a multivibrator, we need to select R1 so that the R1 current is small enough to cause T2 to come out of saturation region. This is the saturation region. We need T2 to come out of this region. Eventually the voltage at T2 collector starts to rise. This rise do not have to be larger because now the positive feedbacks works. When the capacitor C1 is fully charged and this path conducts no more current, the T1 base current is provided only by the R1 resistor, and the R1 does not provide enough base current to T1 to keep the T2 transistor in saturation region, and this is why T2 immediately after C1 is fully charged comes out of the saturation region into the linear region. The voltage at T2 collector starts to rise. So at this point, this point the voltage starts to rise, and this rise in T2 collector voltage again feedbacks via C1 capacitor into T1 base. So this voltage will also rise because the capacitor acts just like a voltage source, and this rise in the voltage at T1 base will further reduce T1 conductivity as the voltage is increasing, and it is a PNP transistor. And this rise in the voltage at T1 base will further reduce T1 conductivity, and T1 VB is reduced, therefore lesser IC, that is collector current, is flowing. The less T1 is driven, which rises the collector voltage of T2 even further, and this raises the T1 base voltage and reduces IC1 and rises the VCE2 even faster due to the positive feedback of the capacitor. So eventually C1 that was previously charged will pull up the voltage on the T1 base beyond the battery voltage, so that T1 and T2 will immediately go into the cutoff region, and the capacitor is in discharging phase. And when the capacitor voltage 0, I mean when the base voltage at this point is around 5 volt, the capacitor will start the charging phase, but this time in the opposite direction, that is in reverse, but the charging current will still flow in the same direction as before. The voltage as T1 base starts to ramp down due to the capacitor charging. Eventually it gets low enough so that the transistor T1 starts to conduct, which pulls the base of this T2 high. This starts T2 into conduction. This time we also have a positive feedback action, and eventually T1 and T2 enter the saturation region, and C1 is quickly discharged and then charged again in correct direction. The left side of the capacitor is more positive than the right, and this is how one complete cycle is performed. So now let's get into the breadboard connections. So for this you need a PNP transistor BC557, an NPN transistor BC547, a 1 kilo ohm resistor, a 1 mega ohm resistor. As I do not have an 1 mega ohm, so I will be using two 470 kilo ohm resistance and a 10 kilo ohm resistance, and a 22 ohm resistance, and that also I do not have, so I am using two 10 ohm resistance. So first we will connect the PNP transistor with the flatter side towards yourself, so that the collector base emitter is like this. Then we will connect the NPN transistor with the flatter side towards you, so that the collector base emitter is in this orientation. Then we will connect the collector of your PNP transistor to the base of your NPN transistor. Then we will connect the emitter of the BC557 to the collector of NPN transistor BC547 via a 22 ohm resistance. I am connecting these two 10 ohms in series to make it nearly same as 22 ohm. Then we will connect the LED with its positive terminal to the emitter of the NPN transistor. Then we will connect the negative lead of the LED to the collector of our BC557 via a 1 mega ohm resistance. Then finally we will connect the capacitor 47 microfarad I am using here to the base of the PNP transistor to the collector of the NPN transistor. Make sure that you put the positive lead of the capacitor to the base. Then we will connect a jumper wire from the emitter of our PNP transistor to the positive rail, another jumper wire from the negative lead of our LED. So now we will connect the voltage supply or the power supply. So now thanks for watching. If you like my video, please hit the thumbs up button and subscribe to my channel for more videos.